Hi everyone, this is Mrs. Trigno and this is page 7 of the Semester 2 Algebra 1B exam review. So this will just cover questions 30, 31, and 32. Question 30 wants us to find the length of side xy. So I'm going to label that with an x, so remember that that's what I'm trying to find. Again, I notice that this is not a right triangle, so I'm going to have to use either law of sines or law of cosines. Now to use law of sines, which is my preference, I have to be able to pair up an angle and a side. So I have one pair here. I have the 32 degrees across from that x. But notice that these two side lengths here, the 14 and the 26, I don't have angles across from them to be able to pair up with. So I'm not going to be able to use law of sines here. So I will be using law of cosines. This is another formula that will be provided for you. Remember I told you that when you're using law of cosines, the most important thing you can do is take whatever it is that you're trying to find and label it A. So in fact, I'm going to scribble out that x and I'm going to call that side A. And if that's side A, that makes this angle A. So I don't care that it's called Z. I'm going to change it and call it angle A. That makes my other two sides B and C, and it doesn't matter which is which. So I'm going to say that the B is the 14 and the C is the 26. Okay. Here's my formula for law of cosines. It says a squared is equal to b squared plus c squared minus 2bc cosine of angle A. Okay? Oh, sorry about that. Let's see here. All right, hopefully you can see that now. A squared equals b squared plus c squared minus 2bc cosine of A. And I'm really just going to plug these values in. Now little a, that's my side A, that's what I'm trying to find. So I'm going to have a squared equals 14 squared plus 26 squared minus 2 times 14 times 26 times the cosine of angle A, which I do have a measurement for here, is 32 degrees. Okay. Now the nice thing is, because my variable is over here by itself, and I have all numbers over here, this whole thing can go straight into my calculator. And again, I recommend doing it all in one shot so that order of operations is not a problem. So I would type, let's see if you can follow this okay. I would type 14 squared plus 26 squared minus 2 times 14 times 26 times cosine of 32. And I end up with 254.6. Remember, that's still equal to a squared. So a squared is equal to 254.6. Now that's not my final answer yet because what I'm really looking for is a. So to get from a squared to a, let's take a square root. So the square root of that 254.6, I end up with 15.95, which I think you'd probably be safe to round up to 16. Okay? And that makes sense with these side lengths. 14 and 26, we could say that that side A is 16. So that's my final answer there. A is equal to 16. Okay, question 31 is asking you to label all of the units on the unit circle. And I'm not going to take the time on this video to label all of them because you all have a copy of the unit circle. And if you don't have one, you're welcome to see me so that you can get them. There will not be a question on the exam like this one where it's asking you to, to label all of them. It'll be more along the lines of I'll give you a blank one and point to one coordinate and say what is the sign at this value or what is the x coordinate at that value. So you will have to know them, but you're not going to have to fill in the entire thing. I will get you started in the first quadrant. First of all, right here at 0, 0, or I'm sorry, this is 0, 0. This next one here, this would be 1, 0, because I moved 1 to the right and 0 up and down. This here is my 30-degree mark, this one here. And so my coordinates there are square root of 3 over 2 and 1/2. This middle one That's 45 degrees. So my coordinates there are square root of 2 over 2 and square root of 2 over 2. And then at 60 degrees up here, it's 1/2 and square root of 3 over 2. Basically, it's reversed from the 30 degrees. Okay, so those are the coordinates in the first quadrant. And then remember, you can transfer those all the way around the circle. Over here in this quadrant, your coordinates are going to be negative and positive. Down here, they're going to be negative and negative. And over here, they're going to be positive and negative. So again, if you're stuck on those, let me know in class and I'd be happy to go through them with you. But I don't think you need to watch me on a video filling in all of those values. You have all of those available to you. So let's take a look at question 32. An airplane pilot cruising at 38,000 feet receives instructions directing him to begin his descent 100 miles from the airport. But this pilot needs to make sure that he's not descending at an angle that's bigger than 5 degrees. So let's find out what angle he would be descending at if he descended 100 miles from the airport. So here's my airplane. Okay, I know, fancy artwork, but there's my airplane. And it's cruising at 38,000 feet, which means it's 38,000 feet off the ground. Okay, so the altitude is 38,000 feet. Oh, there we go. And we want to be 100 miles from the airport. So here's my airport. I'm going to be 100 miles along the ground. And what I'm really looking for is the angle of descent. Now be careful with this angle of descent because this is something that students get confused with all the time. The angle of descent is what angle the plane will have to turn at this way to get down to that airport. So right now the plane is flying along this straight path. Okay, and in a minute we're going to turn and head this way so that we can get to the airport. So this angle here is really my angle of descent. It's not this angle. Angle of descent is where he's turning. Now, we can take that angle and move it down here because of alternate interior angles, and that way it's inside my triangle. Okay, but just make sure that you get that angle of descent in the right place. The other thing we're going to have to do before I start this problem is I have one measurement in feet and one measurement in miles, and that's not going to work. I'm going to need to convert one of those. I find it easier to convert feet to miles because that gives me smaller numbers to work with. So I'm going to divide here by 5,280. Let's see. So this gives me 7.2 miles over here. And I divide that. Okay, if I'm standing at this angle, I see that this is my opposite side. And this here, the 100 miles, is my adjacent side. So if I'm using opposite and adjacent, think SOHCAHTOA, I'd be using tangent. So over here, I'm going to say that tangent of theta is equal to opposite over adjacent, so that would be 7.2 over 100. And then I want to solve to find theta. Now, anytime you're solving for the angle, you're going to end up using an inverse trig ratio. So I'm going to do tan negative 1 of 7.2 over 100. And I can go into my calculator just like that. So in mine, just so you can see it, looks like this. Tan negative 1 of 7.2, whoops. Oh no. Tan negative 1, 7.2 divided by 100. Now I come out with 4.1. So that means my angle of descent is 4.1 degrees. So this question wants to know, will he be able to follow this guideline? He can't descend at an angle bigger than 5 degrees. So is he okay? Yeah, he's okay here because he's only going at an angle of 4.1 degrees. So if I were to answer this question, I would say yes, this would be a smooth, non-turbulent landing. Okay, that's it for this one. We'll pick up with question 33 in just a second.